Assalamu alaikum. How are you all? I hope all of you are well by the grace of Almighty. I am Rizwana Mukhtar, lecturer, Department of Physics, Malestron College. Today I am here to take online lab class. Actually, this class is supposed to be held on our physics lab, but due to coronavirus, as we are not able to take our regular classes, so I am here to take online lab class of physics. I hope this class will help you to understand our today's experiment. So let's start our today's class. Name of the experiment of our today's class is determination the surface area and volume of a rectangular body by slide calipers. You can see there's an instrument in my hand. This is slide calipers. But first question is, why we are going to use slide calipers to measure the volume of rectangular shaped object? Actually, the scale which is available in our house is a meter scale, and through this meter scale we can measure up to millimeter. But if you want to measure the fraction value of millimeter, then you need another scale, which scale is known as vernier scale. In slide calipers, this vernier scale is attached with the main scale. Actually, in slide calipers, there's two scales. The scales with this, you can see there's a long scale. This scale is known as main scale, and the scale which is moved forward and backward direction along this main scale, this small scale is a vernier scale. And the speciality of the vernier scale is that by using this scale we can measure the fraction value of millimeter. Actually, the vernier scale is made of in such way that if the number of division of vernier scale is 10, then it will be equal to the division of main scale 9. And if the number of division of vernier scale is 20, then this 20 division will be equal to the 19 division of main scale. And as there is a difference between the divisions, so we can measure the fraction value of millimeter by using this vernier scale. Now, first thing you have to measure to calculate the length or breadth by using this vernier scale is to measure the vernier constant. Why we are going to measure the vernier constant first? Because in every instrument or in every slide calipers, vernier constant is fixed, which mainly depend on the number of division of vernier scale. Slide calipers which is in my hand, here's the vernier, here's the number of division of vernier scale is actually 20. Here you can see that they numbered the vernier scale in 0 to 10. But if you see it carefully, then you can see that between 0 and 1 there's a line or there's a division also. That means actually the number of division of vernier scale which is in my hand is 20. 0, then 1, 2, 3, 4. If you count this in that way, then you can identify easily that there's actually a 20 division of vernier scale, and this 20 division of vernier scale is equal to the 19 division of this main scale. And you can also see that the main scale's reading is here in centimeter. Okay, so the smallest division or the length of smallest division of this main scale is 1 millimeter. So now we are going to calculate the vernier constant of the instrument which is in my hand. You know that the formula to identify vernier constant VC is equal to S by N. Here S means the number of one smallest division of main scale. Here S means the length of one smallest division of main scale, and you already see that the scale which is in my hand, the length of the smallest division of the main scale is 1 millimeter. That is 1 millimeter. And N means number of division of vernier scale, and the number of division of vernier scale of this instrument is 20. So by divided 1 by 20 we will get the result 0.05 millimeter. Now we have to convert it into centimeter. 0.005 centimeter. Actually we convert it into centimeter because the main scale reading is in centimeter unit. So firstly we convert the vernier constant into centimeter. Now our next step is to take the measurement, or to take the main scale reading and vernier coincidence. So how can we measure the main scale reading and vernier coincidence? Firstly we have to place the object between the two jaw of this. So how can we fix that? By moving this screw we can fix the object between the two jaw. Now the object is fixed. Now I am going to take the reading of this scale. Firstly I am going to take the reading of main scale. Now it's time to take the reading of main scale. So how could we take the reading of main scale? So in this position, where the 0 mark of the vernier scale crosses the mark of the main scale, that mark is the reading of the main scale. There 3 division is crossed by the vernier scale. That means the main scale reading is 4.3. Now the vernier coincidence. So what is vernier coincidence? Actually vernier coincidence means you have to now identify the line where the vernier scale and main scale's division is making a straight line, and here you have to be careful, very carefully you have to identify the line which is actually making a straight line. Now we can see that the vernier scales 4 is making a straight line along the main scale. So this is actually the reading of vernier coincidence or vernier superimposition. Sometimes it known as vernier superimposition. Here 4 means 8, and in this way I am going to take 3 reading. That's we are going to take the average reading, that will to make the measurement accurate. So the first reading was the main scale reading is 4.3 and vernier coincidence was 8, and vernier constant, the value of vernier constant is 0.005. Now the reading, as I am measuring the length of that rectangular shaped object, so the formula to measure the length is L equals to M plus V into V dot C. That means the main scale reading plus vernier superimposition into vernier constant. Here you can see that the main scale reading is 4.3. Vernier coincidence is 8 and vernier constant is 0.005, and after calculating it we will get the value of length is 4.34 centimeter. So our first reading is 4.34 centimeter. Now I am going to follow the same procedure twice for the accuracy of the measurement. Now again I am placing that object between the jaw of these two scales and I am taking the measurement in the same way. Now this time the main scale reading is similar to previous one. You can see that the main scale reading is here also 4.3, but now the vernier imposition is changed. Here you can see that the sixth division is making a straight line with the main scales division. That means now the vernier superimposition will be 6. So now I am going to put the values in the table. So here's the main scale reading is 4.3, but vernier coincidence will be 12 because the 6th number line is making a straight line with the main scale. So after calculating it we will get the value is 4.36 centimeter. That the second reading is 4.36 centimeter. Now I am going to follow the same procedure once again. The value of main scale is not changed this time. That means the value of main scale reading 3 and the vernier imposition this time is 4, that means 8. So after calculating it we will get the value again 4.34. Now I am going to take the average reading. The average reading will be 4.35. Now I am going to take the reading of breadth of this rectangular shaped object. That means as you can see that this is length, and if we put the object in this way this will be the height, and if we put the object in this way this will be the breadth of the object. Now I am going to take the reading of breadth of this rectangular shaped object. So I am putting the object in this way between the two jaws of the slide calipers. Now you can see that the zero line of the vernier scale is crossed the main scale's 3.7 division. So the main scale's reading is here 3.7. And now vernier superposition or vernier imposition. Here you can see that vernier 7th division is actually making a straight line with the main scale. So the vernier scale reading is here 14 and main scale reading is 3.7. Now I am going to put the value of main scale reading and vernier superposition on that table. Here is the main scale reading 3.7 and vernier coincidence is 14, and you know that the vernier constant is 0.005. Now I am going to take the reading of breadth. Now we have the value of main scale reading is 3.7 plus vernier coincidence is 14 into vernier constant 0.005. After calculating it you will get the value of breadth is 3.77 centimeter. That is 3.77 centimeter. Now I am going to follow the same procedure again. In this time the main scale reading is not changed but the vernier imposition is changed. Now the vernier imposition is 3, that means 6. Main scale reading is 3.7 and vernier imposition is 6. So I am going to calculate the reading of breath again. That is main scale reading 3.7 plus vernier coincidence 6 into vernier constant 0.005. After calculating it, you will get the value 3.73 centimeter. That is 3.73 centimeter. Now, third time follow the same procedure. And this time, the value of main scale reading and vernier superimposition is remain constant at the second reading. That means the value of main scale reading is 3.7 and value of vernier coincidence is 0.6. So the value of breath will be 3.73 once again. Now I am going to take the average value of these readings. So the average value is 3.74. Now it's time to take the measurement of height of that rectangular shaped object. Now height means we have to calculate the reading of this portion. Now you can see that the main scale reading is 2 as 0 mark of vernier scale is crossing 2 division of the main scale. So the value of main scale reading is 2 here and the value of vernier imposition is, now we have to be careful, 5, because the division of vernier scale 5 is making a straight line with the main scale's division. That means this is the vernier scale reading. Vernier scale reading is 5, that means 10, and main scale reading is 2. So I am putting the value of main scale reading, that is 2 centimeter, and the vernier imposition was 5, that means 10. And vernier constant is 0.005 as well. So now I am going to calculate the reading of height. Here the main scale reading is 2 plus vernier imposition 10 into 0.005. After calculating it, you will get the value 2.05 centimeter. That means here the value of height will be 2.05. Now I am going to follow the same procedure again. Is there any change or not? This time there is no change. That means the main scale reading is 2 and the vernier imposition is 5 again. You can see that there is no change in the reading. That means the main scale reading is 2 and vernier constant is 5 this time also. So the value remains same. That is 2. Here's 10. That means 2.05. Now I am going to take the measurement, and this time there's a little change in the vernier imposition. Now the vernier imposition is 4. That means the value of vernier coincidence or vernier imposition, these two things are same, is 4. That means 8. So the main scale reading is remain constant, that is 2, and the vernier imposition is 8. Now the value of the height will be 2.04 centimeter. That is 2.04 centimeter. Now it's time to measure the average value is 2.05. So now we know the value of length, breadth and height of that rectangular shaped object, and our today's experiment is to measure the area and volume of that object. So firstly we are going to measure the area, and you know that the formula to measure area into breadth, and the value of length is 4.35 and the value of breadth is 3.74. After calculating it, you will get the value of area is 16.269 centimeter square. Now volume, and you know that the length into breadth into height, and the value of length is 4.35, breadth 3.74 into 2.05. By calculating it, you will get the value of volume is 33.35 centimeter cube. I hope you have understood it. Thank you for being with me.